Okay guys, today we are going to solve this integral using Feynman's technique. I saw on the previous video that you liked a lot Feynman's technique, so today I bring another integral involving this technique. Okay, first we need to find the right place that we are going to put our parameter. If you may think for a second perhaps, but the right place to put our parameter is this. Let our parameter be alpha, I mean, which this integral infinity to 0 ln 1 plus here this 4 will replace with alpha, so x squared divided by x squared dx, right? So we are going to work with this. So we are going to differentiate this. It will be its partial, partial. Here everything will be constant except alpha. Alpha won't be constant here. Wait. Yeah, alpha x squared, everything divided by x squared dx. If we differentiate this, what do we get? This integral which goes from infinity to 0, derivative of natural log. You all know that this will come to the denominator, so we get this. Then we need to differentiate whether is inside of natural log. This is a constant, we get 0. This is a constant, we get this dx. So you can see that we can cancel out this and this, right? And what do we get? We get this is equal to integral which goes to from infinity to 0 dx divided by 1 plus alpha x squared. So here what I'm going to do next, wait sec. Here I'm going to do something really cool because I want to use something here. I'll put alpha on evidence here. If I put alpha on evidence, what do we get? We get 1 over alpha, because if we multiply this we'll get 1, and here will be alpha. If we multiply this we'll get this. I don't know whether you have already seen what I'm doing here, but what I'm trying to do is this. The x here we can put as 1 over square root of alpha square plus x square. This is an integral. What do we get from this integral? We usually get this integral. Integral of this derivative. We get 1 over alpha. If this integral, we usually get this arctange of its x here, x divided by this 1 over square root of alpha, and this we get here multiplies by 1 over square root of alpha. Don't forget that this here we're going from infinity to 0, so this what we get here. This can come here by multiplying. We get square root of alpha divided by alpha. Here if we plug in here infinity, everything here will give us infinity. Arctange of infinity tends to pi over 2. If we plug in here 0, arctange of 0 it's 0, so minus 2. What do we get next? Right here, organize this. We get this. It's equal to square root of alpha divided by alpha pi over 2. But this I can write another way. If we multiply both here by, square root of alpha, what do we get if we multiply there? We get alpha over this, will get alpha divided by square root of alpha pi over 2. So what we can do, we can cancel out this. So what we get this 1 over alpha of 1 over 2 pi over 2. Good. Now we can integrate this in respect to the alpha. Integrate this in respect to the alpha. Here we get I of alpha. If you differentiate this, I need to write this is a constant here. So alpha, when it goes to up, it change its sign here, the alpha. This integral, I know that you know how to deal with. So what we get, it's minus over 2 plus 1 divided here. We get this, only this. So here we get I of alpha is equal to pi over 2. Here it's alpha to the power of 1 over 2. This 2 goes up, this 2. We could have cancelled this in this, but no problem. So what we get here, we get I of alpha. It's equal to what? A plus c. Don't forget plus c here. Don't forget plus c. So we get pi times alpha to the power 1 over 2 plus c. Now we need to find this c. Most of the time, I know, second time that I'm telling this, we let alpha equal to 0. If we let alpha equal to 0, we come back to our integral here. Okay, if we plug in alpha here, I of alpha of 0, it's equal to this infinity 0 ln 1. If we plug in here 0, it will give us 0. So ln of 1 x divided by x, the x here will get 0. 0 divided by this, it's 0. So we get 0. Now we know that this, if we plug in here 0, we'll get 0. It's equal to pi times 0, because it's 0 here plus c. So we can conclude that c is equal to 0. So here we come back to our integral here. I of alpha is equal to pi times alpha, it's alpha to the power 1 over 2. But we let, what we do, we let alpha equal to 4, right? It's 4, alpha is 4. So we'll come here, put I of 4 is equal to pi over 4 to the power of 1 over 2. We know that this is square root. Square root of 4 is 2. So we already get here, it's 2 pi. So this integral here, it's equal to 2 pi. And that's the end. Thanks for watching.